Okay, so you're ready to like really breathe some life into your game, right?
Absolutely.
We're not just talking characters walking around. We're talking like real interaction objects reacting realistically, that satisfying thump when something lands.
Yeah,
That's the magic of Unity
it
physics. And we're
is.
diving deep into the technical PDF, learning Unity physics to unlock its secrets.
And you chose the right place to dive deep, because this PDF, while comprehensive, isn't exactly a beach read.
No.
Luckily, we're here to pull out those golden nuggets of knowledge
Mm-hmm.
and help you apply them to your project.
Exactly. Think of us as your shortcut to understanding complex physics concepts
Yeah.
without the headache of trying to decipher all the technical jargon.
Yeah.
We'll give you those aha moments that'll make you a better game developer.
Because even seasoned devs can forget that physics are the backbone of every game.
It's true.
Remember Pong?
Oh, yeah.
That simple back and forth.
Right.
Even then, used physics to calculate the ball's trajectory and bounces.
Yeah, it's easy to kind of take those basic interactions for granted.
It is.
But now imagine scaling that up to the complexity of like modern games.
Right.
That's where Unity's built-in physics engine comes in.
It does, and this is where Unity really shines.
Okay.
It does so much heavy lifting behind the scenes
Okay.
that you don't have to be a physics whiz to create some really incredibly realistic interactions.
Right.
Think about it.
Yeah.
Would you rather spend weeks coding physics equations
Or
or polishing that awesome level design you've been dreaming of?
no contest. Give me the level design any day. But I'm guessing it's not as simple as just like flipping a switch and it's labeled physics.
Right.
Tell me a little bit more about how this engine actually works.
Well, first you need to understand that Unity has two different physics engines.
Okay.
One for 2D games and one for 3D games.
Makes sense.
It's all about choosing the right tool for the job.
Right. A side-scrolling platformer has very different needs than like a vast open-world RPG.
Exactly.
So how do we actually start bringing objects to life inside these engines?
Okay.
What are those core ingredients?
So imagine this. You drop a ball in the real world.
Okay.
It bounces, it reacts to gravity.
Mm-hmm.
Now let's bring that ball into Unity.
Okay.
Without any physics components, it just hangs there lifeless.
Right.
This is where rigid bodies come in.
Okay, so the rigid body is what gives our digital ball a sense of well-being, a ball.
Exactly. Think of the rigid body as the object's connection to the physics engine.
Okay.
It dictates how the object will react to forces like gravity collisions and even things like friction.
So it's what lets our ball actually fall and bounce
Yeah.
instead of just floating in midair.
Yes.
Okay, that makes a lot of sense.
Good.
Are all rigid bodies created equal? Or are there different types for different situations?
That's a great question.
Okay.
Unity gives you two main flavors of rigid bodies to play with.
Okay.
Physics-based and kinematic.
Okay.
Physics-based rigid bodies are your workhorses.
Okay.
They're completely governed by the physics engine.
Mm-hmm.
You set them up.
Yep.
You apply forces and let the engine do its thing. Think back to our ball example. That's a classic use case for a physics-based rigid body.
It's like setting up a domino effect, but instead of dominoes, it's like forces and reactions all playing out in real time.
It is.
So what about these kinematic rigid bodies? When would you use those?
So kinematic rigid bodies are where you, the developer, get to take more direct control.
Okay.
Instead of being driven by the physics engine, their movement is determined by your code.
So it's like the difference between a pinball bouncing around a machine versus like a carefully choreographed dance routine.
Exactly.
Right.
Think of moving platforms in a platformer game,
Right.
or maybe a door that swings open on command.
Okay.
Those actions are too precise, too intentional to be left to the whims of the physics engine.
Right.
That's where kinematic rigid bodies shine.
It's all about that level of control. Now we've got these objects that are imbued with these physical properties.
Right.
But how do we actually make them interact with the world around them,
Okay.
with each other?
That, my friend, is where colliders enter the picture.
Okay.
Imagine a collider as this invisible force field surrounding your object,
Right.
defining its shape and boundaries as far as the physics engine is concerned.
Okay, so it's the collider that prevents our ball from just phasing through the floor like a ghost.
Precisely.
Okay.
Without colliders, our digital objects would be oblivious to each other's existence,
Right.
happily passing through walls and other objects like they weren't even there.
Yeah.
Colliders are what make those interactions and ultimately your game mechanics possible.
It's like they're wearing armor,
Yes.
protecting them from all those chaotic physics interactions.
Yeah.
And just like real armor, I'm guessing there are different types of colliders for different jobs.
You're catching on.
Okay.
Just like with rigid bodies, Unity gives you a variety of colliders to choose from,
Right.
each with their own strengths and weaknesses.
Okay.
For simple objects, you've got your basic shapes, box colliders, sphere colliders, and capsule colliders.
So a cube-shaped crate would get a box collider. A soccer ball would get a sphere collider. Simple enough.
Exactly.
But what about more complex objects?
Yeah,
Let's say
yeah.
we have that really intricate spider model that's in the PDF.
Okay.
How do we handle that?
So that's where things get interesting.
Okay.
You could use a mesh collider,
Mm-hmm.
which uses the actual polygon mesh of your object for collision detection.
Okay.
This gives you the most accurate collision.
There's always a but.
Always a but.
I'm sensing like a performance warning on the horizon here.
You already know.
Okay.
Mesh colliders are notoriously resource intensive,
Okay.
especially if you have a lot of them in your scene.
Right.
Using too many can bring your game to a crawl.
So it's a balancing act, like
Well-
always in game development.
Right.
Finding that sweet spot between realism and performance.
Exactly.
Are there any tricks to optimizing this whole collider situation?
Absolutely.
Okay.
One technique is to use compound colliders.
Okay.
Instead of using a single complex mesh collider, you can strategically combine multiple basic colliders
Okay.
to create a more efficient approximation of your object's shape.
So for our spider frame, we might use a capsule collider for the body, some sphere colliders for the joints,
Right.
and maybe a few box colliders for the legs.
Exactly. You're essentially building a custom suit of armor that's both effective and lightweight.
I like it.
Now, let's say you've got your rigid bodies and colliders all set up, and your game world is starting to feel alive,
Yeah,
but now you need to manage how all these objects interact with each other.
because the last thing we want is for our carefully crafted world to descend into this chaotic free-for-all of objects colliding with everything in sight.
And that, my friend, is where the power of the collision matrix comes in.
Ooh, the collision matrix.
Yes,
Sounds impressive.
it is.
Is this where we get to play physics overlords and lay down the law of interaction?
You got it.
Okay.
The collision matrix is essentially a rule book that dictates how different types of colliders interact with each other.
Okay.
Think of it like a spreadsheet, where each row and column represents a different collider type, and you can check or uncheck boxes to determine which pairs should trigger a collision event.
So I could set it up so that enemy projectiles collide with the player, but not with other enemies.
Precisely.
Right.
This level of control is crucial for creating complex game mechanics
Right.
and ensuring that your game behaves the way you intended.
Right.
And there's another layer of control here, literally.
Okay.
Unity lets you organize your game objects into different layers, just like in image editing software.
Okay, I think I see where you're going with this.
Okay.
So instead of managing collisions for every single object individually,
Yes.
we can use layers to group them
Yes.
and define interactions on a broader scale.
Exactly.
Right.
You can have a player layer, an enemy layer, a projectile layer, and so on. Then, within the collision matrix, you can specify which layers should interact with each other
Okay,
and in what way.
gotcha.
For example, you might want your player to collide with the environment and enemies,
Sure.
but you probably don't want them colliding with their own projectiles.
That makes perfect sense.
Right.
This whole system is so elegant, the way that it lets you manage complexity without getting bogged down in those individual interactions.
Yes.
It's like conducting an orchestra of physics.
That's a great way to put it.
Right.
And just like a conductor can fine-tune the performance of each instrument, you, the developer, have a similar level of control over your game's physics.
Right. It's like we've set the stage, we've assembled the actors, and now we get to direct the entire play.
Yes.
We've talked about these tools, but the PDF also hints at scripting. How much coding do we really need to do to like wrangle these physics interactions?
So the beauty of Unity is that it gives you a lot of control right out of the box.
Okay.
You can create some really compelling physics-driven gameplay just using the components and settings that we've already discussed.
Right.
But for those times when you need to go off script
Right.
to create some truly unique and unexpected interactions,
Okay.
scripting gives you that power.
So it's like adding those special effects to our physics masterpiece.
Exactly.
What are some examples of how scripting can really take things to the next level?
Okay, so imagine you're creating a game with bouncy platforms that launch the player upwards.
Okay.
With just a bit of code,
Mm.
you can detect the collision between the player and the platform,
Okay.
and then apply an upward force to the player's rigid body.
And the result is that really satisfying burst of momentum.
Okay, that's cool.
Yes.
It's like giving those platforms a little bit of personality,
Yes.
a way to interact with the player that goes beyond just like a simple bounce.
Right.
We also briefly touched on that cool trick with the friction values.
Yes.
Can you refresh our memory a little bit about how that works?
Absolutely. So the PDS goes into detail about adjusting the friction values within something called physics materials.
Okay.
If you want an object to like glide effortlessly across the surface like ice,
Right.
you'd create a new physics material
Okay.
and tweak its friction values to almost zero.
So that's how you get those like slippery surfaces in games?
Exactly.
It's amazing how like such a small tweak can have such a huge impact on the feel of the gameplay.
It makes me think of those ice levels in platformers where one wrong move and you're just sliding into oblivion.
Exactly. It's all about finding those little details that can
Yeah.
really elevate the player's experience.
Right.
But remember, just like anything in game development, it's
Right.
about finding the right balance.
Always.
You mentioned it earlier, using too many mesh colliders can really tank your game's performance.
Yeah, it's all about compromise.
Yes.
We want those realistic interactions, but not if it means like a choppy frame rate that makes the game unplayable.
Exactly.
Are there any other pro tips from the PDF that we should keep in mind as we venture out into the world of Unity physics?
Yeah, one thing that often trips up new developers is the temptation to overcomplicate things.
Okay.
Remember that collision matrix we talked about?
Yes.
Really powerful tool, but you don't need to create a separate layer for every single object in your game.
Right.
Sometimes a simpler approach is best.
So it's like organizing your code.
Exactly.
Find those logical groupings that make sense and keep things manageable.
Yes.
You don't want to get lost in a sea of layers.
Exactly.
Okay.
So as we wrap up our deep dive into Unity physics,
Okay.
I want to leave you with, we've really only scratched the surface of what's possible here.
There's always more to learn.
Always more to learn. What we've given you today are the fundamental building blocks.
Right.
It's up to you to experiment with them, to combine them in new and unexpected ways.
I like it.
Don't be afraid to get creative, to break the rules, to see what happens when a physics-based rigid body collides with a kinematic rigid body in a shower of particle effects.
The possibilities are endless.
They are endless.
It's like we've given everyone the keys to the physics playground.
Go have fun.
Now go forth and make some awesome games. That's a wrap on another deep dive. Until next time, keep experimenting, keep learning, and most importantly, keep creating.